Welcome back to the deep dive. And today, I have to admit, I am actually pretty nervous. I don't say that lightly. Usually, I'm the one who's ready to just jump right in and get learning, but today I'm feeling the heat.
You do look a little stressed today. You've got
Yeah.
that very specific night before the final exam look in your eyes.
Yeah, the caffeine jitters are definitely real right now.
Yeah.
It's because I have been staring at the study guide for Phase V of the framework all week, model evaluation. And honestly, it just feels like hitting a brick wall.
It is the moment of truth for the project.
Right, it's the moment of truth. We've spent all those previous deep dives building the model and cleaning the data and training algorithms, and now we are at Phase V. And in my head, evaluation should be simple. You turn the machine on and you ask if it works. But the framework, it splits that simple question into all these different dimensions.
It really does.
And specifically, I am completely drowning in the difference between model performance results and KPI measurement. They honestly sound like the exact same thing to me. Did the model work? But the practice questions treat them like they are totally different universes.
That is actually the number one killer on the certification exam. So
Yeah.
you are definitely not alone there. It trips up almost everyone the first time they see it.
It just feels like semantic hair splitting. Why do we need two totally different terms to ask if we did a good job?
It definitely feels that way at first. But let me ask you this. If you go out and buy a sports car
Right.
and it drives 200 miles an hour on the track, that's performance. The engine performs exactly as the engineers designed it to.
Okay.
But if you bought that specific car to drive your 3 kids and a large dog to soccer practice, and there are no back seats, did it meet your KPI?
Oh, I see where you're going with this. The car is high performance, but it totally failed the actual mission I bought it for.
Exactly. Or you can flip the scenario. You buy a giant minivan that fits your whole family perfectly, so your KPI is met. But the engine catches fire every time you drive over 40 miles an hour. So the performance failed. That is the exact distinction we're dealing with today.
Okay, that actually makes a lot of sense.
And it isn't just about passing a test. Phase V is what I always call the fail path.
The fail path. That sounds incredibly ominous.
It's the part of the project where things go wrong. It is where you have to make hard choices. Do we kill the project entirely? Do we go back and fix it?
Mm.
Or do we pretend it's totally fine, launch it into production, and get fired 6 months later because the AI did something catastrophic?
Yeah, let's avoid getting fired. That is my primary personal KPI for today. So I asked you to come in today, not just as an expert, but really as a coach. I need you to walk me through this fail path sequence properly because I keep getting the order of operations wrong.
We could absolutely do that. Let's start from the top. If you had to frame Phase V in a single sentence, what is it?
Based on my somewhat panicked reading this week, I'd say it's checking if the model is good enough to deploy to the real world.
That is a bit too vague for the exam. Phase V is exactly this. It is where we strictly measure technical and business success against the bars we set back in Phase I.
Against the bars from Phase I, that's the key part, right? We are making up new rules at the end of the game.
It is the only key.
Yeah.
We are not making up new rules here. We are looking directly at the contract we signed in the beginning. Now, structure-wise, if you look at the guide, we are looking at 2 task groups.
Right, I have those here, model evaluation and review.
Correct. And both of those groups are marked as critical priority.
Critical. So that means this is a must-pass section of the exam.
Absolutely. You cannot fudge Phase V. If you don't understand the difference between a technical fail and a business fail, or if you don't know the exact sequence of how to fix a fail, you will not pass the certification.
Wow.
And more importantly, for everyone listening, in the real world, if you mess this up, you will launch bad AI. So here's our game plan for this deep dive. We are going to role play.
Okay, I'm game.
I am the coach. You are the candidate. We're going to go through the top terms and the top concepts. But here is the ground rule for everyone listening to us right now. Don't just listen passively. When I pose a scenario to our host here, I want you to mentally pick an answer before I reveal the correct one.
So everyone listening needs to commit to an answer in their head.
Exactly, because if you don't commit, you won't feel the sting when you get it wrong, and you won't remember the trap when you're sitting for the actual exam.
I'm ready to be stung. Let's dive right into segment 1 and hit the top terms.
All right. We have 3 critical terms that define this phase. We're going to do a plain language definition, a metaphor, and then a scenario. First up is model performance results.
This is the one I struggle with so much. This is the purely technical one, right?
Strictly technical. This task answers exactly one question. Did the model meet the technical targets that we set way back in Phase I? The bar is fixed, and it does not move to match what the model actually produced.
Technical targets, so things like accuracy or precision?
Yes. Or MAPE, which is mean absolute percentage error.
Wait, can we pause on MEPE for a second? I see it in the notes constantly. Mean absolute percentage error. I know I should probably know this by now, but break that down for me simply.
Yeah. It is actually a very simple concept, but the name sounds intimidating. Imagine you are building a model to predict the price of a house. You predict a house is worth $100,000, but it actually sells for $110,000.
Okay, so you're off by $10,000.
Right. That is a 10% error. Now imagine another house. You predict $100,000 again, but this time it sells for $90,000.
So you're off by 10,000 again, another 10% error.
Exactly. But in raw numbers, one error is positive 10,000 and the other is negative 10,000.
Yeah.
If you just average those raw numbers together, they would cancel each other out to zero.
Oh, I see. Plus 10 and minus 10 average to 0. So it looks like your model is perfect, even though it was wrong both times.
Precisely. So the absolute part of the name means we just ignore the negative sign. We only care about the magnitude of the mistake. We take all those percentage errors, make them absolute so they're all positive, and average them together. That is your MAPE.
So if my model has a MAP of 8%, that just means on average it's wrong by about 8% either way.
Exactly. And back in Phase I, you signed a document saying this model is entirely useless to the business if the error is higher than 8%.
Okay, that's the line in the sand.
That is the line. And the rule for Phase V is that the bar is fixed. Think of it like a structural engineer doing a load-bearing inspection on a new building.
I like that analogy. Let's build a building.
You are building a bridge or a building. The blueprints say this structure must hold a 50-ton load. That was decided before you laid a single brick, because that is the safety requirement for the trucks that need to drive over it. Now, you finish the bridge, you test it, and it only holds 45 tons.
It failed the test.
It failed. You cannot look at the bridge and say, well, 45 tons is pretty close, and it was really hard to build, so let's just change the requirement to 45 tons.
Right, because the bridge is going to collapse when a 48-ton truck tries to drive over it. The trucks aren't going to get lighter just because we changed our paperwork.
Exactly. The specification is fixed. The inspection measures the bridge against the specification. You do not measure the specification against the bridge.
Okay, I totally get the concept now. Give me the scenario.
All right, this is based on Item 1, Scenario A in your study guide. Pay close attention to everyone listening because there's a very specific trap here regarding what counts as technical. A logistics company has reached Phase V evaluation for an AI route optimization model. Back in Phase I, they specified an acceptable model performance value of a MAPE of no more than 8%.
So the error rate has to be 8% or lower. Got it.
They run the evaluation test. The model achieves a MAPE of 11.5%.
Okay, so it missed the target.
It missed, but the data science team argues that this is actually a very strong result given how complex the data was. The historical delivery data was messy, traffic patterns change. They say 11.5 is great contextually. Plus, the model is already routing trucks faster than the humans did, so they recommend proceeding to Phase 6.
To deployment.
Yes. So, candidate, what is your answer? Do they proceed?
Well, I mean, I really sympathize with the data science team here. If the data is messy, that really isn't the model's fault. And if the experts are telling me this is the best we are realistically going to get, why would I fail it? Plus, you said the trucks are already routing faster, so the business is getting value. I feel like it's too rigid to say no. I would say yes, they should proceed.
That sounds like a very pragmatic, reasonable, real-world management decision.
So I feel a massive but coming.
But that answer is incorrect.
Really? Even with the trucks moving faster?
Especially with that. The model failed the technical threshold. In this framework, a technical failure is a failure, regardless of how close it came or how hard the data was. Go back to the bridge. The engineer says the steel was low quality, so it only holds 45 tons. But it's a great bridge considering the bad steel. Do you drive your family across it?
Put that way, absolutely not.
Technical failure is binary. The model is a tool. If the tool does not meet the technical spec, it is a failed tool. You cannot move to Phase 6.
But what about the trucks moving faster? Doesn't that count for something?
That is the trap I warned you about. That is the fixed note in the source material. We use MAPE here because it is a technical metric. Delivery time reduction is a business KPI.
Wait, so delivery time isn't a performance result?
No. How accurate the math is, that is the performance result. What happens in the real-world faster deliveries is the business KPI. This specific task we are talking about only measures the math. It does not care if the trucks are faster. It cares that the math is accurate to within 8%.
So I was mixing up the technical metric with the business outcome.
Exactly. Never confuse technical metrics with business KPIs. So the memory hook for everyone listening is this. The specification is fixed, the inspection measures against it.
The specification is fixed. Got it. Okay, 0 for 1 on my end. That was a bit of a rough start. But I see the trap clearly now. Let's try the second term.
Term number 2 is model iteration approach.
This sounds like the process of fixing the problem when we fail.
It is, but it is strictly about how you decide to fix it.
Yeah.
Here is the plain language explanation. If evaluation fails, like our logistics model just did, you cannot just say, all right, let's go back and fix it.
Why not?
Because you must produce a structured, documented decision that identifies the exact root cause and the specific return phase, whether that is phase 2, 3 for at F.
So you don't just automatically rewind one step.
No. The metaphor here is an aircraft accident investigation report.
Okay, high stakes again.
Imagine a plane has a serious malfunction. Before the aviation authority issues the formal order to ground the entire fleet, the investigators have to figure out exactly why it happened. Was it a pilot error? Was it a software glitch? Was it a mechanical failure in the engine?
They need the root cause.
Right. They cannot just issue an order to ground the fleet and say, we will figure out why later. The investigation report has to come before the directive. That report is your model iteration approach.
Okay, that makes sense. Give me the scenario for this one.
This is based on item 2, scenario A. A retail bank has an AI credit scoring model that fails phase V evaluation.
Okay, so we have a failure.
The project manager immediately records the failure in the review process documentation and directs the team to return to phase 4 to retrain the model. No root cause analysis is documented before this decision is made.
Phase 4 is model technical construction, where the training happens.
Correct. So what is your call? Is the PM following the framework?
I mean, in the real world, this sounds super efficient. The PM is taking charge of a failure. They made a quick decision to retrain so the team isn't just sitting around waiting. I feel like my boss would love this kind of bias towards action. So I'm going to say this is an acceptable approach.
You are falling for the speed trap again.
I am, aren't I? I am trying to be the hero project manager who fixes things fast.
The answer is incorrect. The required sequence is completely violated here.
Because they skipped the analysis part.
Yes, the model iteration approach task was entirely skipped. You cannot issue the formal no-go decision, which happens in the review process, until the root cause and the return phase are fully documented in the model iteration approach.
But wait, what if retraining the model is actually the right answer? What if that's what it needs?
But how does the PM know that? How do they know retraining will fix it? Maybe the historical credit data they gathered was biased. That would be a phase 2 failure. Maybe their mathematical definition of a good credit score was wrong from the start. That is a phase I failure.
Right. Garbage in, garbage out.
Exactly. If the data is bad and you just send them to phase SOAR to retrain, you are just going to get the exact same bad model just a few weeks later.
You're just burning money and time on a blind guess.
Precisely. So the memory hook here is this. Grounding the fleet without analysis is a decision without a correction path. You are just guessing.
Grounding the fleet without analysis, I like that. It feels like bureaucratic red tape at first, but it's really about safety and precision. It's making sure we aim before we shoot.
Exactly. Which leads us perfectly into term 3, the review process.
Is this the meeting where everyone gets yelled at for the model failing?
Hopefully not, but it is a formal meeting. The plain language definition is that this is the formal go or no-go gate. It is the final task of phase V. It formalizes the decision to either advance to deployment or iterate back to a previous phase.
Okay, so this is just the stamp of approval or denial.
Yes. And crucially, it does not do the analysis. It just stamps the result of the analysis that was done in the previous step.
Okay, what is the metaphor here?
Think of it like a judge's sentencing decision in a courtroom.
Okay, we're in court now.
The trial is over. The evidence has been established. The jury has already spoken. The judge is now reading the formal sentence. The judge does not stand up during the sentencing hearing and say, wait a minute, let me go investigate the crime scene myself right now.
Right, because that part of the process is already over. If they start investigating now, it's basically a mistrial.
Exactly. The sentencing is just the formally recorded outcome of the process.
All right, hit me with the scenario. Let's see if I can get one right.
This is based on item 3, scenario B. A government agency's model fails evaluation. The PM convenes the review process immediately to record a no-go decision.
Okay, they're having the meeting.
A reviewer in the meeting points out that the model iteration approach, the root cause analysis we just talked about, hasn't actually been done yet.
Oh boy, I know where this is going.
The PM argues, look, we are all here in this meeting right now. We are all smart people. We can just discuss it and decide the return phase during this meeting.
Right.
Why schedule two separate meetings when we can just do it all in one?
Man, this is where real-world me fights exam me so hard. Real-world me is screaming, please do not schedule another meeting. We have too many meetings. The PM sounds like a hero for saving everyone an hour next week. Let's just figure it out in the room. I want to see the PM is right.
And real world, you would fail the exam once again.
I knew it. But why? Why is it so strictly forbidden to just talk about it in the room with all the experts present?
The answer is incorrect, because the judge cannot investigate the crime during the sentencing.
Right, the metaphor.
The review process exists to formalize the decision that was produced by the model iteration approach. If you have not done the rigorous analysis before the meeting, the review process literally has nothing to ratify. You are just brainstorming in a conference room. You are not conducting a formal governance gate.
It's really about accountability, isn't it?
It is entirely about accountability. If you just decide in the meeting based on a gut feeling and some quick chat, and you turn out to be wrong, who was responsible? Where is the documentation proving you looked at the data? It doesn't exist.
So the sequence is incredibly rigid. Analysis happens first, then the meeting happens second to sign off on it.
Always. You cannot sentence the defendant before the investigation is complete. That is your memory hook.
You cannot sentence the defendant before the investigation is complete. Okay, I am really starting to see the pattern of this framework. It is fundamentally designed to stop us from rushing.
It is designed to stop you from guessing. AI projects fail constantly in the real world because people guess. They say, oh, it failed, let's just retrain it. Or, it's close enough, let's just pass it. CPM AI says, stop guessing, measure it, analyze it, then decide.
I love that. Okay, let's move into segment 2. We have our top terms locked down. Now we need to tackle the top concepts. These are the logic rules that tie the whole phase together, right?
Right. And these are usually the hardest ones for candidates because, again, they clash heavily with modern agile software development thinking.
I mean, I love agile thinking. Move fast, adapt.
The exam does not love that when it comes to evaluation. Concept 1 is this. Evaluation applies phase I criteria. It does not define them.
This goes back to our bridge metaphor from earlier.
Yes. The confusion from students usually sounds like this. I thought if we learned something brand new during the project, we should be agile and update our goals to reflect reality.
Yeah, that sounds totally reasonable to me. Iterative development. If we realize halfway through that our original goal was way too hard, we should change the goal.
Here is the strict clarification from the study guide. Phase V applies the criteria set in Phase I. It does not set them. Changing the bar to match where the arrow landed requires formal governance reapproval. It is never just a quick team decision.
Okay, give me the hard scenario for this one.
This is based on Item 4, Scenario A. An energy company is building a model to predict equipment failure on their power grid. Back in Phase I, they set a target recall of 94%.
94% recall. Got it.
They run the evaluation. The model achieves an 89% recall.
So it missed the target by 5 points.
It missed. But the data science lead argues that 89% is actually an incredibly strong performance because they discovered a lot of unexpected sensor noise in the live data.
Okay.
So the lead recommends updating the Phase I documentation to an 88% target right before they hold the review process meeting.
Oh, that is sneaky. They want to lower the historical bar to 88 so their 89 suddenly looks like a passing grade?
Precisely. They want to rewrite history so they don't have to report a failure.
I mean, on one hand, that feels like straight up cheating. But on the other hand, if the sensor noise is a real physical problem on the grid, maybe 94% was literally unrealistic from day one. If they update the document, they avoid a failure on paper and save everyone a ton of red tape. I feel like a lot of corporate teams would absolutely do this.
A lot of corporate teams would absolutely do this, and a lot of those teams would be violating the core principles of the framework.
So it's strictly wrong.
It is incorrect.
Yeah.
This violates the governance principle entirely. You were supposed to measure the model against the standard, not redefine success to comfortably match what you happen to produce.
But what if 94% really is physically impossible because of the sensors?
Then you go back to governance. You say, we cannot meet this requirement due to hardware limitations. You present your findings, and you get formal approval from the sponsors to change the scope of the project. You do not just quietly edit a document to make yourself look like a winner.
That makes perfect sense. It's about transparency to the stakeholders.
Think of it like a bar examination board.
Like for lawyers taking the bar exam.
Right. A graduating class takes the bar exam. The passing score was set by the board months ago. The class takes the incredibly hard test, and they all score lower than expected. They cannot petition the board to retroactively lower the passing score just because they didn't hit it.
Even if they argue the questions were unfair.
It doesn't matter. The standard is the standard. If you lower the standard after the fact, you let incompetent lawyers into the courtroom.
And if we lower the AI standard, we let incompetent models run the power grid.
Exactly. So your contrast summary is this. Phase I sets the bar. Phase V measures the jump. Never lower the bar after the jump.
Phase I sets the bar, phase V measures the jump, never lower the bar after the jump. I am definitely writing that one down. Okay, concept 2.
This is the big one, the one you were stressing over at the very beginning of the show. Technical pass and KPI pass are completely independent requirements.
Right. The did it work confusion.
Here is the clarification straight from the guide. They are independent hurdles. A technical pass does not substitute for a KPI pass, and a KPI pass does not substitute for a technical pass. You must have both.
Okay, let's test this because this is definitely where my brain gets twisted. Give me the scenario.
This is item 5, scenario B. A pharmaceutical company is building a clinical trial matching bottle.
Very high stakes. Literal life or death.
Extremely high. The phase I technical threshold was set at 90% accuracy for matching patients. The actual result in phase V is 84%.
Okay, so that is a technical fail. It is not accurate enough.
Correct. But the phase I KPI target was to reduce patient recruitment time by 20%. The actual result is that it reduced time by 28%.
Wow, so that's a massive KPI pass. They completely crushed the business goal of saving time.
They did. So the business sponsor stands up in the meeting and says, look, the KPI proves the real-world value of this tool. We save 28% on time. That represents millions of dollars in R&D savings. Who cares if the accuracy metric is a few points low? Clearly, the model is working for the business.
You know, I am 100% with the sponsor on this one. If the entire goal of the project is to save the company time, and we saved way more time than we even hoped for, why does it matter if the internal accuracy math is a little low? The business is thrilled. I say pass it.
And you just deployed a highly dangerous drug to the wrong people.
Whoa, that escalated fast.
This is exactly why the framework is so uncompromising here. Your answer is incorrect. You absolutely cannot proceed to phase 6.
But why not? The business value is huge.
Think about how the model might have achieved that incredible speed.
How?
If a hospital stops checking safety requirements, they could admit patients very quickly. If this model stops checking if the patients actually have the correct genetic markers for the disease, it can fill the trial in a single afternoon.
Oh, no.
The model is fast because it is sloppy. It is matching the wrong patients. That is why the accuracy dropped to 84%. Sure, you filled the trial in record time, which makes the KPI look amazing, but you filled it with people who do not fit the medical criteria.
So the trial itself is going to fail.
The trial will fail, the drug won't get approved, you saved a few weeks of time up front, only to waste billions of dollars and potentially hurt people later.
That is a terrifying perspective. I didn't even think of it that way.
That is exactly why technical pass and KPI pass are independent. A technical failure means the machine itself is not behaving safely or as designed. It might be getting that amazing speed boost precisely by making dangerous mathematical shortcuts.
Speed isn't everything if you're matching the wrong people.
Exactly. Think of the metaphor like the drug approval process itself.
Okay.
You have safety trials, which are your technical metrics, and you have efficacy trials, which are your KPIs. Efficacy asks, does this cure the disease? Safety asks, does this kill the patient?
Right. You need both to be true.
This scenario you just approved is like saying, well, the drug cures the disease 28% faster, so let's just completely ignore the fact that it failed the safety threshold and causes liver failure.
Yeah, put that way, it sounds completely insane.
It is insane. But in a high-pressure business meeting, when millions of dollars in savings are on a PowerPoint slide, people forget the safety checks. Your summary here is this. Technical pass checks the engine. KPI pass checks the destination. You need both to drive the car.
Technical checks the engine. KPI checks the destination. Got it. I will definitely not let the business sponsor bully me next time.
Yeah.
2 independent keys to turn the lock.
Very good. Let's move to concept 3. This is the final piece of the logic puzzle for phase V. The fail path has a sequence. Iteration must happen before review.
We touched on this a bit with the grounding the fleet metaphor earlier.
Yes, we did. But the specific confusion here is usually about where to go when you iterate. Students almost always assume, oh, if the model fails, we just go back to phase 4 to retrain it.
Isn't that what machine learning is, though? You just retrain the algorithm on the data until it gets it right.
Not always.
Yeah.
Retraining in phase 2 is only the answer if the problem is actually in the training parameters. But what if the original data you collected was completely wrong? Then you need to go back to phase 2. What if the business problem was defined poorly? That is a phase I return.
Okay, show me how this looks in a question.
This is item 6, scenario B. A supply chain prediction model starts drifting and failing evaluation.
Okay.
The team does the root cause analysis. They discover the model is failing specifically on a brand new product category the company just launched. Why? Because that category did not exist and was never included in the phase 2 cognitive data requirements.
So the model literally doesn't know this new data exists because nobody asked for it back in phase 2. It's completely blind to it.
Correct. Now, a junior team member wants to just go straight to phase 4 to retrain the model to fix the drift.
Just hit the retrain button.
Yes. What is your analysis as the PM?
Well, let me think. If you go straight to phase 3 and hit retrain, what exactly are you retraining it with? The data requirements for the new products are still completely missing back in phase 2. So you wouldn't be pulling the new data. You would literally just be retraining the exact same blind model on the exact same old data.
Bingo.
So retraining won't fix anything. You have to go all the way back to phase 2, formally update the data requirements, actually gather that new product data, and then you can retrain it.
Exactly. The candidate gets one right on their own.
Yes. Finally.
Your logic is flawless. The root cause is a phase 2 data coverage gap. Retraining in phase 4 without fixing the data pipeline first will just reproduce the exact same failure.
So what's our contrast summary for this one?
Model iteration approach finds the root cause. Review process signs the order. Never gets the return phase.
Never gets the return phase. And the metaphor for this?
A hospital incident review board. The patient outcome was poor. The board has to determine exactly where the care pathway failed before they can close the case and recommend a fix. Was it the initial diagnosis, which would be phase 1? Was it the lab test results getting mixed up, which is phase 2? Or was it a mistake during the actual surgery, which is phase 4?
You can't just send the surgeon back to the operating room if the lab gave them the wrong chart.
Exactly. Find the root cause first. Okay, I feel like you have a solid grasp on these concepts now.
I really do feel a lot better about this. It isn't just a simple, did we pass question? It's a very specific, rigid grid of independent checks.
It is. And once you see the grid clearly, you completely stop guessing.
All right, Coach. I think I am ready. Let's put this all to the test.
Excellent. Let's jump into segment 3, rapid fire.
Oh, boy. I'm suddenly sweating again.
I am going to fire 4 short scenarios at you. One for each major area we covered. You have to answer each in a single sentence. I will score you correct, close but wrong, or strictly wrong. Are you ready?
I am as ready as I'll ever be. Let's do it.
Scenario 1. The model has a 96% precision rate, which is a technical pass, but it completely misses the revenue KPI target, which is a fail. Can we approve this model to go to phase 6 deployment?
No, because technical success does not substitute for business failure. They are independent hurdles.
Correct. You need both keys to tune the launch lock. Scenario 2. The project manager notices model drift and immediately schedules the formal review process meeting to decide the next steps with the team.
That is totally fine as long as they decide quickly. Wait, no, wrong. They skip the model iteration approach analysis entirely.
Correct. You almost fell right back into the speed trap.
I caught myself. You cannot schedule the review process meeting before you do the actual root cause analysis.
Exactly. You cannot sentence the defendant before the investigation is complete. Scenario 3. Root cause analysis shows the model failed evaluation because we are missing training data for a specific geographic demographic.
You must return to phase 2 to fix the cognitive data requirements before doing anything else.
Correct. Do not just default to phase 4 retraining. You have to fix the data pipeline first. Scenario 4. The model achieves a 91% accuracy against a strictly documented 92% threshold. The team votes to just round up because it's only a 1% difference.
I mean, it's close enough to pass, no. Absolutely wrong. The bar is fixed and you cannot change it without formal governance.
Correct. Adjusting technical thresholds requires governance reapproval, not a casual team vote.
4 for 4. Well, with a couple of very slight stumbles in there.
I will definitely take it. That was a very solid performance.
Phew. Okay, let's bring it home. My heart rate is finally going down.
So, summarizing our session today, what fundamentally changed in your understanding?
I think two really big things changed for me. First, before today, I genuinely thought technical results and KPIs were basically interchangeable. Like, if one was really good, it made up for the other being a little bad. Now, I know for a fact they are completely independent hurdles, the engine check and the destination check.
That is a crucial distinction that will save you on the exam.
And second, I used to think a failure automatically meant we just go retrain the model. Now I know that a failure means we have to stop and do the model iteration approach to analyze the root cause and find the actual correct return phase, whether that is phase 2 or phase 1.
Excellent summary. And I will leave you with one final memory anchor. Remember the specific fix we talked about at the very beginning regarding what counts as technical?
Ah, the MAPE versus delivery time thing?
Yes. Never confuse a business KPI, like a delivery time reduction or cost savings, with a technical metric, like MAPE or accuracy. Phase V requires you to distinguish between those two incredibly clearly. If you put a KPI into the technical evaluation box, you will fail the exam questions every single time.
Technical is strictly math. KPI is strictly business impact.
Every single time.
This has been unbelievably helpful. I genuinely feel like I can actually tackle Phase V now without just throwing my textbook across the room in frustration.
That is always the goal. Keep practicing those scenarios in your head.
I definitely will. Thank you so much for walking me through this. And thanks to everyone for listening to the deep dive.
Remember what the coach says.
Pick your answer before the reveal.
Every single time. See you next time.